Hi Tabitha, you asked for help with numbers 27 and 28 on section 2.2, and I have them highlighted here. I'm going to begin with number 27. Okay, let me scroll over to the next page. I've written it here. Number 27 is y equals 1/3 absolute value of 2x minus 1. And so let me go back to the previous screen. Here you're asked to find basically everything you can know about this function. Got to graph it, find the zeros, the x and y intercepts, domain and range, intervals of increase, decrease are constant, and the relative and absolute extrema. So it's a lot, but so here we go. Like I said, I put the function here, and the way that I go about starting this to graph it is to consider first this function. So this function here, we're going to think of it as just a function without the absolute values, and instead of absolute values we turn them into parentheses so that we can try and highlight what's going on without absolute value, and then once you insert absolute value, then you can see how that affects the graph. Okay, so looking at this, we have, okay, I'm going to rewrite it this way. So it's the y equals, and instead of absolute value, we're going to use parentheses 2x minus 1. And as you know, what this gives you is a line. And it's the line, let's rewrite it here. Y equals, distributing the 1/3, you'll get, 2/3 x minus 1/3. Okay, so you can see here that this is the slope. The slope is 2/3, and remember it's rise over run. And this right here, right here is the y-intercept. Okay, so we can begin graphing this line, and then from there, again, going backwards, figuring out how the absolute value affects it. So beginning with the y-intercept, okay, I'm going to do my best to figure out where's negative 1/3. It's about right here. And then remember, slope is rise over run, so we got to go up 2 and then over 3. So let's go. There's up 1, up 2, and then over 3. 1, 2, 3. So this would basically be like our next point on the graph. What you see here, the bigger green dots. And so let me join them, okay, the best I can. And just draw a line through them. And, well, that's roughly what's happening there. So that's the line that we get from this. So this is the line, okay? Now what we need to do is figure out from here what happens when you do absolute value, okay? And so absolute value would pretty much, in this case, because absolute value is affecting, let's see, it's affecting this part, okay? When you're doing absolute value, around this, it would be the same, around this underlined yellow part, it would be the same as if you were doing it around the whole thing. So, because 1/3 is positive, and so it's basically the absolute value of this line. What happens when you think about taking the absolute value of this line? So, looking here, okay, the absolute values, as you know, are all positive values, or non-negative values. So anything that's below the line, so all of this part, is going to be whoops, excuse it. So anything that's below, so right here, all of that, we're going to have to flip it above the x-axis. And so instead of this downward piece right here, instead of this, we're going to write it so that it's above the line, or graph it so it's above the line. And that's how you do these absolute values. So, and I have to just roughly do it. And the best way to do that is to, yeah, there's no best way to do it. You just have to be, just be good at flipping these things around. And it's still the same slope, except now that it instead of positive, it's negative. All right. Let's see. So we have, whoops, excuse. Okay. That's basically the line. So, as you can see, what happens is, let me erase this bottom piece, because now that's no longer part of our graph. And this remaining piece right here is what you get for the absolute value. So this, let's see, this is going to be the graph of y equals absolute value of 2/3 x minus 1/3. Okay, which is the same as the actual function itself. Okay, your original function. So from here we can read off a lot of information. Okay, for instance, and we can see it from the function itself. We have these pieces right here, these points that are important, and these intervals. So where is the function going to be crossing the y-intercept, the y-axis? That's the y-intercept. And so in this case, since it was negative 1/3 originally, this would be now positive 1/3. So some of the first bits of information would be y-intercept is y equal to positive 1/3. All right. The x-intercept would be where the function is 0, right? And so if you look at above here, again looking at this right here, when is that part 0? Well, that's 0 when x is equal to 1/2. That's right there. So you can see that x equals 1/2 is the x-intercept. Okay, and that's the only point where the x values are, where you have roots, where the graph crosses the x-axis. And then we have to figure out intervals of increase and decrease. So f of x increases basically from 1/2 to infinity. And because you see the slope is upward right here. So you have this upward slope. So you have this increasing part. And then you have that your function, f of x, decreases over the interval, negative infinity to 1/2. Okay. And again, you can see that being on the other side, right? You have, let me change this color so it's different. Blue. So you can see it's going to be decreasing on that side. So that's when it decreases, and then this is where it increases. And so you have increasing and decreasing intervals. You have x and y intercepts, and It has an absolute minimum. So the absolute minimum occurs at x equals 1/2. F of x is, f of 1/2 is going to be 0. So that's the minimum value. It has no max. And we also have domain and range. You can read it off this graph. Domain, all the possible x values. Well, that would be negative infinity to infinity. And what about the range? The range are all the possible y values, or the heights, right? And so in this case, it's going to start at 0 and then go up from there. So go off to infinity. So that's pretty much everything there is about this function.